A week ago, we had a GC Pro from TEAMGROUP, which was Gen 5x4 with, I think it was 1 or 2 terabytes. I can't remember. But regardless of that, what we have right here is something even better. It outperforms GC Pro. This right here is TEAMGROUP T-FORCE GE Pro, Gen 5x4 with, this is 2 terabytes. You also have it in 4, 8, and lower than that. But 1, 2, 4, 8, this is insane. 8 terabytes of Gen 5 SSD. I mean, that's just brilliant. And the thing is, the best part is, it reaches read speeds above 14,000 megabytes per second and write speeds above 11,000 megabytes per second. So we have to put that in test and basically to see if this will actually take the crown of the fastest SSD currently on the channel. Now, the thing is, I noticed in some, I think it was a TikTok or it was YouTube Shorts actually. Yeah, it was YouTube Shorts where I did a video about GC Pro where I placed the graphene sticker prior to placing the passive heatsink of the motherboard. And since I never done this benchmark, I wanted to do it now just to debunk all the myths and everything all together. And of course, it was true. So there are going to be one benchmarks exclusively without the graphene sticker, and then I'm going to place graphene sticker after that and run benchmarks again just to see the thermals and how will it react, how will it act, and what are the thermals going to be. Is there going to be any significant difference? Is there going to be any problems or whatever? And yeah, it's going to be interesting. The thing is, I use this GE Pro on the ASRock X870 Steel Legend, and it actually has thick thermal pads from both sides. And this is a double-sided SSD. So yeah, it kind of goes into that segment where you might consider, well, will it fit? Now, the graphene sticker isn't that thick. It's barely visible, to be honest. It's just like a sheet of paper. And it's graphene, so it should nicely dissipate the heat, but definitely not without additional heatsink, because this isn't enough, and you'll see why. Now, additionally, what I wanted to say is this SSD has Innogrid IG5666 controller, new 4K LDPC code, graphene heatsink, as already stated. It has DRAM cache. Of course, I don't think I ever encountered a Gen 5 SSD that didn't have DRAM cache. Now, there are multiple options that you could actually buy from TEAMGROUP in terms of the size and the heatsink, because first of all, you have from 1, 2, 4, and 8 terabytes. You have graphene heatsink and you have the Airflow 1 heatsink. These come in a bundle, and honestly, I don't know if I could find them on Amazon or anywhere else where I usually place the links in the description, but I'll try to find as much as possible so you can choose the best one that suits your needs. Now, as I stated, it goes up to 14,000 megabytes per second read, and in addition to everything, it has smart monitoring system, which basically is software that tracks SSD status at all times and conducts fast and simple settings and inspections to monitor the SSD quality status and performance, basically health and everything else. Now, the SSD has also security isolation, basically meaning a data security isolation mechanism, new generation error correction technology with the 4K LDPC, what I mentioned earlier, and then we have 5-year warranty. Now, when we're talking about some durability, we're having 1200 TBW, you have DRAM cache, of course, and basically the 2 and 4 terabytes are the fastest. If you go to 8 terabyte, it goes up to 13,500 megabytes per second, and the write speed goes up to 11,000. So yeah, that's quite interesting to know, basically. Now let's go quickly through the benchmark just to give you an idea. And I'm gonna go specifically no graphene. So ASSD read speeds without the graphene sticker, 10,233.22 megabytes per second. Write speeds 10,728.02 megabytes per second. The thermals were 56 degrees. With the graphene sticker, 10,272.28 megabytes per second read, and write speeds 10,096.78 megabytes per second, 55 degrees. So we have 1 degree lower with the graphene sticker. Now let's go with AutoDisk benchmark. AutoDisk benchmark read speeds 13.19 gigabytes per second, write speeds 11.31 gigabytes per second. With graphene, 13.09 gigabytes per second, and write speeds 11.31 gigabytes per second. So speeds are there, just like minor difference, but that is definitely relevant. When we go and check out the thermals, no graphene 74, graphene sticker 71. So 3 degrees lower. And we'll get to the interesting part. Crystal disk benchmark. Read speeds 14,102.16 megabytes per second, write speeds 12,103.55 megabytes per second with the thermals 81 degrees. With graphene sticker, 14,065.93 megabytes per second and write speeds 12,043.59 megabytes per second. The thermals are 75. That's 6 degrees lower with the graphene sticker. So I don't know what to say. I guess I was right. And then we go with IOPS read. We have 1.2 million IOPS, and for the write we have 924,879 IOPS. Regardless, I'm just curious. I wasn't even concerned about the speeds. I was actually looking forward to seeing the thermals. And what I want to mention in the Autodesk benchmark, as already stated in the prior videos, there are no huge difference in speeds when you take into consideration the consistency. So you don't have to worry about this one being thermal throttled in both scenarios. No graphene or graphene sticker, even at 81 or 74, it didn't thermal throttle. And then we go with 54.9 gigabyte file. Well, basically what happens here is just regular what happens with every SSD. 3.94 gigabytes per second read, and write speed is 3.54 gigabytes per second. In 3D Mark storage benchmark, we have, well, basically you see that the average is 524.79 megabytes per second, and the average access time is 57 nanoseconds. And the overall score is 3107. So basically, we did get much higher scores when we were talking about 3D Mark storage benchmarks, but regardless of that, other speeds, what I tested, are incredible. What I said regarding the graphene sticker, definitely place it on the SSD because we have loads of other SSDs that come with stickers such as this one, not these ones that are here, and if you remove it you lose your warranty, but these ones are important because they do dissipate the heat and they need to be placed on your SSD. That's the most important thing, right? And if the SSD already comes with a graphene sticker, aluminum sticker, or whatever they do or placed on the SSD, you can't remove it. You could, of course, you can heat it up. Eventually, the glue will release and you can take it off. But there is no point because, as you can see in this scenario with these benchmarks, the thermals were much better with the graphene sticker than without it. So I rest my case with that. That's solved, and we busted the myth. But regardless of that, this is definitely and currently the fastest SSD on the channel and what I tested out so far. So without a doubt, the GE Pro does the outstanding work. But what I wanted to say, apart from the GC Pro, which has a bit lower speeds, and I think that was Clev Genuine G560, wasn't satisfied with the speeds and the performance, like consistency and everything, with the Gen 5 SSD. And with this one, we actually get something quite interesting. It doesn't heat up to reach that thermal throttling phase. It doesn't affect the speeds at the higher thermals, and it still outperforms every SSD currently, again, on the channel, because I'll have more Gen 5 SSDs to review, and you'll see the benchmarks quite soon as well. But until then, we have TEAMGROUP T-FORCE GE Pro 1, 2, 4, and 8 terabytes. You can go with graphene sticker, or you can go with Dark Airflow 1, which is in some sort of a bundle, and I'm not quite sure in what regions that will be available. But regardless of that, I'll try to find as much links as I can and place them, of course, in the description below, so I can ease up the process of you choosing your perfect SSD for your next build. That'll be all for today, guys. Thank you for watching, and of course, if you liked the video, well, don't forget to subscribe, hit the like button, click the notification bell, and just leave a comment if you have something to add to the benchmarks, to the SSD, general Gen 4, Gen 5 SSDs, or just start a discussion. That's it for today. Bye-bye.